Okay, so these examples from 7.2, again, like inverse, cosecant, and those aren't the most practical functions, so you're probably not going to use these in your engineering classes when you build a bridge. But they're good for understanding, so they're good brain training to understand how inverse trig functions work in general. So let's look at inverse secant of 5. And from the last video, we know that inverse secant of 5 would be the same thing as inverse cosine, because secant and cosine are reciprocals of each other. And the way that we were able to work through it was to say, if we change from inverse secant to inverse cosine, we can change from 5 to 1/5. So we know those are the same expression. 1/5 is still not a place around the unit circle that's, one of those magic places that we know about. So this just becomes calculator work at this point. So we grab the calculator and we would do inverse cosine, and that's the second of the cosine key. So second cosine gives you inverse cosine of 1/5. And that's about, let's see, make sure I'm in the right mode. Yep, radian mode. That's about 1.37. So approximately 1.37. Okay, so there'll be a few examples like that, but there's going to be a lot more examples like this second one. And here's where we really get into the weightlifting for your brain. Again, this is to make your brain stronger, not necessarily to do a practical engineering problem. But they're saying, let's find so order of operations is do the inside part first. So normally we would think about doing that part first and saying, what's the inverse tangent of 6/7? And that's some angle. That's what inverse tangent does, is figures out the angle. And then whatever that angle is, we'll say, let's take the secant of that angle. And we are going to be able to work this problem without ever figuring out what the angle actually is. We'll never know that the angle is like 32 degrees or something. But what we are going to do is draw a picture of the angle. And to do that, we are going to go back to the idea of the unit circle, or to be a little more precise, we're going to go back to the idea of any circle, not just a unit circle. So let's look at a circle centered at the origin. And keep in mind that the definition of tangent is the y-coordinate over the x-coordinate. Let's put that somewhere. Say tangent is the y-coordinate over the x-coordinate. So we've got some angle here where the y-coordinate is 6 and the x-coordinate is 7. So we've gone 6 over, and we've gone 7 up. So I'm kind of drawing a picture of the angle. So this angle here, I'm just going to call it theta. That angle, whatever it is, would have a tangent of, I would label that backwards. I'm sorry. This would be y over x. Sorry, that's 6 y-coordinate, 7 for an x-coordinate. And what we really want is the secant of that angle. And keep in mind that secant is 1 over cosine. So cosine is your x-coordinate. And secant, therefore, would be 1 over your x-coordinate. So we know our x-coordinate is 7. And therefore, the secant of this angle, which again, we still don't know the actual angle measurement, but I do know that secant is 1 over the x-coordinate. So it is 1 over 7. Now, a lot of these questions, they might ask you for, instead of secant, they might ask you for, well, I don't know, let's just look at another example. Okay, so let's do one more example. So let's look at cosecant of inverse cosine of u. So rather than a specific number, they're giving us a general number, which means our answer is going to have some u's in it as well. It's going to be an answer in terms of u. And we're going to kind of pull the same trick in the sense that I'm going to draw a unit circle or a non-unit circle. And to do that, I need to look at u as a fraction. So I will look at u as being u over 1. And keep in mind that as we draw this unit circle, that cosine, that's a better circle, that cosine is defined to be, let's see, let's keep my colors consistent here. Cosine is defined to be the x-coordinate. And when we were on non-unit circles, cosine was x over radius. So it turns out here we actually are on a unit circle because the radius is 1. So we have some angle in here. I don't really know how big of an angle it is, but I'll just draw it something like this, whose x-coordinate is u and whose radius is 1. And I want to figure out the cosecant of that angle. So keep in mind that sine is the y-coordinate, or the y-coordinate over r if you're not on a unit circle. And cosecant is the flip of that. So cosecant is the radius, or 1 in our case, but in general the radius over y. So we need the radius, which we already know is 1, but it's going to be 1 over, and we need the y-coordinate here, and we don't have that yet. But fortunately, this is a right triangle, and we know that a squared plus b squared equals c squared, so we can set that up and get a y-coordinate out of that. So let's see, we need a different color to do that, so let's set that up in orange, and let's say that u squared plus this unknown y-coordinate, so y squared, equals 1 squared, which is just 1. And we're trying to get an expression for y, keep in mind here. So subtract u squared from both sides. And y is the square root of 1 minus u squared. Normally this would be plus or minus, but we know from our picture that we're going in the plus direction, so we'll use the positive square root. So this remaining side here, this question mark, is actually the square root of 1 minus u squared, which means all the way back in our original question, when they were asking for the cosecant of this angle that has an inverse cosine of u over 1, that the cosecant is just 1 over the y-coordinate. So that's 1 over the square root of 1 minus u squared. And again, that's the answer you would actually put in for my math lab. So again, maybe not the world's most applied problem, but it really gives you a chance to do the dance with cosine and cosecant and really know your stuff.